students. Alright, today we are going to look into a topic known as projectile motion, okay? Projectile. So from the video you just watched, you can see a boy who threw a ball into a net, okay? And that ball seems to go through a path like this and fell into the net, okay? So this part is known as parabolic part. So in that regard, projectile motion takes a motion, it looks like a motion like this, which means a motion of a body launched in a space, influenced by force of gravity to move in a parabolic path. That's the meaning of projectile, okay? That's what you just watched now. Then, if you check the other link I have, use your iPad and your laptop, you check it now, you can see the link I gave you for simulation. You can use it to practice some of the things I'm going to talk today at home. But just check it. You can see the gun, you can rotate it into different angles, right? Then there is a red button down there. When you press it, it will shoot out a bullet. And that bullet, you see the path it follows, which looks like this as well, okay? Good. So you can see the other one next to it. You can use it to wipe it out if you want to start afresh, okay? Alright, so then explore the whole features and see how it goes, okay? Alright. Now, if you look at that very stuff, you will see where if you place that gun at 45-degree angle, you see that the bullet seems to move further. There is no other angle that will get as further as the 45-degree angle of that gun barrel, okay? So it means that when you place a projection at 45-degree angle, it seems to have a higher distance covered when it's projected, okay? Alright. Now, for today's topic, we are going to look at the objectives, which is things we are meant to know today. The first one is to identify and explain the properties of a projectile. Okay, so properties of projectiles are things like range of projectile, time of flight, maximum height, gravity, trajectory, and all that. Okay, so we are going to look into that. Then the second objective of today is to apply the principle of independence of motion to solve projectile motion problems. Okay, so we are going to look into this today. Alright, before we start, I want us to recall into what we did in our last class, which is derivation of equations of motion. We were able to derive equations of motion, at least about 3 main equations of uniformly accelerated motion, the one that is uniformly accelerated, okay? Alright, so in the equation, you recall that we have the first equation to be V is equals to U plus AT. Then the second one, S is equals to UT plus half AT squared. Then the third one is V squared is equals to U squared plus 2AS. These are 3 main equations of motion. You remember how to derive it. All of you know it, right? Good, good. I love that. I love that. So in these equations now, we are going to use it to get our properties of projectile. But look at this very equation. It is supposed to have both positive and negative, because positive means when it is accelerating, when it is moving uniformly, steadily, accelerating steadily, okay? Alright, so in that regard, it is positive. But when it says retardation or deceleration, or you heard that a vehicle matched a brake or applied a brake, it means that it is retarded, so it's going to be negative. So this thing should have both positive and negative signs. So it depends on what is said, you know the one to apply, okay? Alright, so these 3 equations of motion, because of the topic we have today, projectile, which is a motion of a body launched in space, influenced by what? Gravity. So it's not going to be this one. This is for things that are happening here. Or this one is going to be for the one that is influenced by gravity, which is U. You can put the plus and minus, then GT, then we have have the, instead of S, you can put H to signify height because it is happening in a space. So there is height in that case. You have U, T, then plus and minus, half, G, T, squared. It is G because this one is acceleration, but because of launching in a space, it is now gravity. Okay? Then we have this one to be V squared is equals to U squared plus and minus 2GH. These are the three equations we are going to use to prove our case today. Alright, before I continue with this, I want us to recall the resolution of vectors we just did. Okay? In that resolution of vectors, we are still going to use it in this projectile motion. This one and that. So in that one, you see where we have a thing like this. You can see we have this to be U. Then you have this one as S-axis to be US. This one as Y-axis to be what? UY. Then you can have an angle theta. And in that resolution, you remember that we said that if you want to resolve this thing, because of vector, it means something that has magnitude and direction. So we want to resolve these things in components so that it will have a particular direction. So in component means you have to resolve it in S and Y component. So in resolving in S component, so it has to have a singular direction. So we are going to resolve these two, so they will be one. So we use this one, this acronym. So let me put it this way. So TOA. Okay? So we want to look among this acronym, the one that will take cognizance of this and this. So in resolving, you can see that it is CAP that goes, which is cos theta. All of you can remember, right? Cos theta. CAP adjacent, which is US, all over hypotenuse, which is U. So you can now make subject to be US is equals to over 1. US is equals to U cos theta. We have resolved this into the S direction. So resolving to this side, because there is angle here, we have to use sine to resolve this into one singular place, okay? So resolving to this side, we now use sine. Using sine, you can see that this thing, it seems there is an imaginary. This is also UI. So we can now say, so opposite. That opposite is going to come here, which is also this. So we use sine, is the best one to use. Sine theta, I hope you are seeing the board, right? Okay, alright. Sine theta is equals to so opposite, which is U, Y, all over, so opposite all over hypotenuse, which is U. So opposite all over hypotenuse, which is U. Then making the subject, you now have U, Y to be equals to what? U sine theta. Okay? Alright, so these are the things we have to remember and use it to solve our projectile motion problem. Alright, coming to that now, we now start with our projection. If a ball or anything was projected in a space, so definitely this is the plane of projection. So there is, this is the Y component vector, then this one is the S component vector. You can call it, if you like, S. Then you call here, this is our height. Call here the range where it fell. Okay? So here, which is our Y component vector, there is gravity pulling this way, but we can take it up to this place. So you can call this place UY. Then this place now seems to have this. We call this place U itself. This place will now be US. Okay? So it's now looking like this very thing I did here also. Okay? You can see it that way. So if something was projected this way now, a body was projected, the initial velocity at which it was projected, it will remain what? The same. It doesn't change, okay? But what changes is this man, because what changes is this. It will now be reducing it as a result of the influence of gravity until it gets to this point. So at this point now, you can see that the final velocity is equals to 0. So when it starts coming down, it will have an initial velocity which is also 0. So this is how it works, okay? Now let's look at, let's use this using the second equation to start, you will now take this one. This is the second equation of motion under gravity. So you can call it, let me put it, H is equals to U T. Because we are going up, when the projection is moving up, it's going to observe minus negative sign, okay? It's going to observe minus because it is going up, it is going against the force of gravity. But when it is going down, it is going to observe plus, okay? So because it's going up, we are going to use minus, so minus half gt squared. So in this case now, we have to use this man. You can change it if you like. You can change it to y. Then, okay, let me make it 0 because we are trying to find the time of flight. Let it come. Time of flight. I will give you the definition. Time of flight simply means the time it takes a projection to return to the same horizontal plane where it was projected from. Okay? The time it takes it to return back to the same horizontal plane where it was projected from. Okay? Alright, so we have to find the time of flight. And in finding the time of flight, we use this equation. In using this equation, in time of flight, because it has landed, the time it takes it to return back to the horizontal plane, at that point, the edge, the height becomes 0. So we are going to call this man here 0. Okay? Then this u, we are going to resolve it according to our resolution of vector. We are going to resolve it this way because we are talking about this man and this man. When it is moving up, only this side and this side is observed because there is a force of gravity pulling it downwards, which is also this, and there is a initial velocity that it was used to be projected. So in that case now, we have to resolve it this way, which is vertical, which is u sine, let's check it, u sine theta. Where is that? U sine theta. Okay, this one, u sine theta dot t. But I want to do something. I will not put it t, I'll put it t0. T signifies time of flight, if you like t. Okay? But here, I'll put it t0. I'll explain why. Minus half g t0 squared. Okay? Alright, so having gotten that now, we want to get t as the subject of the formula. I take one t here, I take one t here, I bring it out. T, which is equals to u sine theta, t0, then minus half g t0, okay, is equals to 0. So you can see that if you now make t0 the subject of the formula, it becomes 0 because if this one divides with 0, it becomes 0. Okay? So this one is the time of flight at the initial point of projection, which is at this point of projection. That's the time of flight. Okay? Then we have to find the time of flight when it's now landed at the same plane, the same horizontal plane where it was projected from. So finding that now, we can still use this same formula, which is this one. But in this case now, we can still use it h because we want to now find the main time of flight t. Okay, so in that case now we use h, this man, equals to u t minus half gt squared. So here we have 0, then equals to u sine theta dot t, the capital letter t, minus half gt squared. But in this case now, what you have to do is you have to take this one, maybe this side, and see how it goes. So you can say 0 is equals to u sine, okay, I can write u t sine theta minus, I take this one up, gt squared over 2. So in this case now, if you like, I can say, take this, or I can make the LCM, sorry. Now so making the LCM of this, you now have something like 2, then this side should be something like 1. 1 into 2 is 2. 2 into this will now be 2ut sine theta minus 2 into 2 is 1. multiply this one to be gt squared equals to 0. Then this one plus multiply, it will be 0. That's 2 times 0 will be 0. So this one times will be 1. Okay? So we now have something like 2ut sine theta minus gt squared is equals to 0. So I have to take this one this way, or I will first and foremost, let me take this one this way. We now have 2u, okay, let me take this one this way. You have minus gt squared is equals to, this one going over, will be minus 2ut sine theta. Then it remains this one. Instead, I can now say divide both sides by minus gt. Okay? Dividing both sides, divide both sides by minus gt. Okay? Now we have minus gt squared all over minus gt is equals to minus 2ut sine theta all over minus gt. So minus cancelling minus, g cancelling g, t cancelling t, it remains 1t here. Minus cancelling minus, you have t is equals to, okay, t cancelling t here. You have t equals to 2u sine theta all over g. So this one is the time of flight when it hit back to the same plane where it was projected. Okay? But we have alternative way of getting time of flight. That alternative way, we'll be able to get the time of flight here at this maximum height. Then whatever it is, we multiply it by 2 to get this same time of flight. But because of time, I'll leave that for today. Next class, I'll teach you that. But let's continue. We have the maximum height, which is one of the properties of projectile. So the maximum height, what we'll do is to use the maximum height. We use this this equation of motion, which is the last equation to find the maximum height. So in that one, we have v squared is equals to u squared then minus 2g, okay, 2g h. But the maximum height, at maximum height, velocity is 0. So the whole of this will come to 0, which is equals to, we use the normal resolution of vectors, which is u sine theta. Then you square it, okay? You square it minus 2gh. So in squaring it, you now have 0 is equals to u squared sine squared theta minus 2gh. Okay? So you now have to find make h the subject of the formula. So making h the subject of the formula, you take this one this way. You now have minus u squared sine squared theta is equals to minus 2gh. So you can see, making h the subject of the formula, you have minus u squared sine squared theta is equals to minus 2gh all over minus 2g all over minus 2g. Then minus 2g, we cancel minus 2g. Minus, we cancel minus. We now have our h to be equals to u squared sine squared theta all over 2g. This one is the formula for the maximum height. If you want to obtain the maximum height, okay, the highest height of the projection, that's the formula there, okay. Then we have the range, which is the range of projectile, which is the it is defined as the horizontal distance from the point of projection to the point where the projection hits the projection plane. The horizontal distance, okay? We are from the point of projection back to where the projection hits the plane, which is this. That's the range. So the formula for getting the range is by quoting the okay, let me play this side. Let me play this side and continue. Maybe. Okay. So in getting the range now, we have range to be what? velocity is equals to distance over time. Therefore, you can now say distance is equals to velocity times time. So you can now call it distance is now standing for r, then vt. Okay? You should now have that, but because we are talking about range, which is the horizontal distance, we are going to use that resolution of vector, the one that says cos theta, because that's the one that resolves towards the horizontal. Okay? You remember, right? Good. Alright, so in that case now, I have r equals to what? This v is going to be u cos theta times t. But the t we are going to use here is not going to be the t for time of flight, which is this one, which is, okay, let me put it there, times t first. Then r equals to u cos theta dot the t here, which is 2u sine theta over g. Okay? Now, having gotten it now, you now check this whole thing. You have cos theta here. Now, according to trigonometry, you can remember the day I did it with you, right? Okay. According to trig, when you have 2 sine theta cos theta, it will be equals to, or it will be identical, okay, to sine 2 theta. Okay? Now we are going to use to replace this. So now I'm going to rearrange this to make more sense. R, which is equals to, I'm going to rearrange it. Here we have this to be 2u squared. I will take sine theta first. Sine theta cos theta all over g. But because of this trig that I put here, which is 2 sine theta cos theta, 2 sine theta cos theta is going to be sine 2 theta. We now have our range r to be equals to what? U squared. Then 2 sine theta cos theta will now be sine 2 theta all over g. So this is the formula for range. R equals to u squared sine 2 theta over g. Then if you want to get the maximum range, let me play this side. I'm playing. Oh, I hope you're enjoying the class, right? Good, good. Now, to get the maximum range, all you have to do, know that to get the maximum range, according to what I put in that link there, you have to make this man 45 degrees. To get the maximum range, which is maximum range, which is arrow max, okay? To get the maximum range, all you have to do is to put 45 degrees, because it is at angle 45 degrees that you can get the farthest distance when the projection lands back to the same plane, okay? Alright, so you have r equals to u squared sine 2 in bracket 45 degrees all over g. So you have, which, okay, arrow mass. Now you have arrow mass is equals to u squared. This will going to give us sine 90 degree over g. And sine 90 is equals to 1. Check it there, sine 90. Yeah, good. 1. So 1 times u squared is going to be u squared. So we have our arrow mass to be equals to what? U squared over g. This is the formula to get maximum range. Okay? Any confusion? Any problem? Alright. I love that. This class is so good. Alright, so you have to do some exercise. You have to do some exercise. You have to copy it now. In this exercise, I'm going to write out which is a projectile is fired with initial velocity. Are you writing? A projectile is fired with initial velocity. A projectile is fired with initial velocity of 100 meters per second at an angle of 30 degrees with the horizontal. Calculate A, the time of flight. B, the maximum height attained. C, the range. Okay? So you have to do it. I've already given you the formula for all these things, so you can use it to try it out now. Okay? Look at the formula for range in case you forgot. Okay? This is the formula for time of flight, okay? Then we have the formula for maximum height. So I say calculate what? The time of flight, the maximum height, and the range, okay? Alright, so if you do it, remember that the angle is 30 degrees. We have, okay, let me now check what you are doing, okay? Okay? Alright, so what will happen is that let me use your own and check if you are correct, okay? Let me use what you are doing, let me check if it's correct. Now, we have time of flight, which is this formula, T, they say calculate the time of flight as the first question, 2u sine theta all over g. So what you have to do is 2 times what? U. What's the initial velocity they say? They say a projectile is fired with initial velocity of 100 meters per second. You put 100, sine what? Theta. Angle of what? 30 degrees all over. Gravity. Force of gravity is always 10 meters per second. Okay? Now if you calculate it, it will give us an answer. Okay? The same thing is applicable to the maximum height. Look at the formula there. You square it, you press sine square angle 30. Okay? You get it. I hope all of you are following, right? Then you do the same thing in range. Alright. I have some questions in Google Classroom. You can go to the Google Classroom, check some of the questions I said when you get to home. Okay? Check some of the questions, about 10 questions to give you feedback, instant feedback. Okay, do it now. I think you will do it now. It will give you instant feedback. If you do it, it will give you instant feedback. I think the best thing is go home with it and do it, okay? But you get the answer. I will watch it. I'll see the answers each and every one of you get, okay? Then you try to derive this whole equation. Try to learn it because I'm going to call you out maybe the next class to know if you get it, okay? Now let's check if we actually learned what we are supposed to learn today, which is the objective. We say identify and explain the properties of projectile. Okay? And I told you properties of projectile is time of flight. You all understood how we got our time of flight, how we got our maximum height, and how we got our range. Okay? Alright, so I think all of you understood that, right? So go home and practice it very well. Then apply the principle of independence of motion to solve projectile motion problems. At least we have solved one problem here. We have solved one problem. We have other problems like the ones I gave you in the Google Classroom. So you can go there and check it out. Solve all of them. Okay? Then when you solve it, I think we have made a very good progress. So that is it. Okay? If you have any problem, anything at all, try to reach out to me. I will always be available. Okay? Amaya, I hope everything is okay. Alright, alright. See you guys next time. Thank you so much. Thank you. I love you.